Now, let's talk about this little guy. This energy card quad node design is pretty neat because it's funny, when we first started out there talking to folks like Paul's team and said, hey, Paul, we got this really great server idea. Can you build a server out of this? And his guys look at us like, yeah, but we're going to have to study it for a while. It's going to take some engineering. We don't know about how to build a fabric for this and so forth. So we say, tell you what, let us help you. We'll put all the complexity on this one card. The fabric's on the card, okay? Fabric's on the card. And it exports 80 gigabits of bandwidth down through this card, these connectors, down to a motherboard that you see here, and then imports them back up across all of these other cards. Makes it really simple to design these platforms and helps us get to market quickly so we can start experimenting with it. So we can start working with end user customers to say, hey, what is it good for? What problems does it really solve for you? And how can we get the software community lined up to help you solve those problems? This is a slide that HP showed this morning. I thought I'd just reprise this slide. It's my favorite slide. I have this slide under my pillow. My wife thinks I'm totally insane. This slide shows 400 servers, 10 racks of dual socket x86 on the left. Dual socket, 1U dual socket. These are dense servers, okay? And adds up all the things you need to plug them together. So it's got 10 racks, it's got 20 switches, it's got 1,600 cables, and it has burns about 91 kilowatts across those racks. The equivalent Calxeda capacity for the target workloads we're going after is a half a rack, and still have room left over for some flowers or a bookshelf up there, maybe a little, we're from Austin, so we'd probably stick a beer cooler in there. And so half a rack of our servers will equal 10 racks of x86. And you know what? Nobody's going to really care about that. What they're really going to care about are two numbers on this slide. Top numbers in green, $3.8 million over a 3-year total cost of ownership versus $1.2 million for the HP Calxeda-based system. And the other numbers people are going to care about is at the bottom, 10 kilowatts versus 90 kilowatts. So everybody says, sounds great, where's the software? Where's the software? We heard Mark Shuttleworth talk about Canonical. Right? Canonical's already announced support for Ubuntu for ARM as a first-tier platform with the 10.11 release. So we're very excited about that. And so now from there, we build up the software community for our target markets. Now, these are guys who announced back in June they would support Calxeda. And we're very, very proud to have them on board because they're exactly focused on the markets we talked about. Talk about cloud computing and big data and analytics, okay? And they're all signed up, they're ready to go. What about all this porting costs? It's really hard to port. You know what? Most of this stuff is interpretive code. It just runs. You just download it. It's just Linux, and it just runs. What about more complex codes? Fine, C++, compile it. It's not like no one's run Linux on ARM before. There's over 4 billion instances of Linux running on ARM today. It's in everything from your cell phone to your microwave oven, your routers at home, your printers. It's all running Linux on ARM. There's plenty of tools. There's plenty of capability on that. So that's our story. We're sticking to it, really helping rewrite the TCO equation. And we're really excited to be on this journey. As Barry said, this isn't the destination. We're just getting in the car. We've got a long way to go, but it's going to be a great journey, and we think it will truly transform the industry.